Alright guys, today we're going to talk about surface area and volume of cones and pyramids. And in this situation that we have here, we have a cylinder and a cone. Both have the same height and the same base. And what we want to see is how many of these cones will it take to fill up one of these cylinders. So I'm going to use some Dr. Pepper, and we're going to test this to see how many we get. So here's our first pour. Here is our second pour. Cat's making a table wiggle. Here is our third pour. And you can see our Coke is right up to the very top of the cylinder, which means that it took 3 of the cones to fill the cylinder. Okay, so I'm going to pour that up before the cat spills it. The cat is actually rubbing against my tripod right now. Okay, we spilled a little bit there. And let's move to a pyramid and prism. Okay, so hopefully the cat will let us do this without knocking over our stuff. Okay. So, here's our prism. It's a cube. And our square base pyramid. They have exactly the same size base. They're exactly the same height tall. And in this experiment, we are going to be pouring up okay, we've got one, two, and 3. So again, it took 3 of our pyramids to fill up our prism. Okay, but I'm not totally convinced yet. I'm still not completely sold on whether this is a rule that's always going to be true. So I'm going to try one more time, but with a different type of prism and different type of pyramid. This time, what I'm going to use is a triangular prism and a triangular base pyramid. Okay, so how many times will it take? Okay, I'm going to pour up, and again, the base is the same size and the height is the same size. So here's one pyramid full of Coke. Two. And 3. So, that shows that if we have a prism or a cylinder, and then I have a pyramid or a cone with the same size base and the same height, then it will take exactly 3 of those pyramids to fill up the prism with the same base and same height, or it'll take 3 of the cones to fill up a cylinder with the same base and same height. All right, so let's move over. And I'm going to try to move this without pouring it all out and making a spill. We did make a little bit of a mess. The cat kept bumping into the table, and that's causing us issues. Okay, but I'm going to try to move over, and let's look at what this does to our formulas. Okay, so we said that the volume of a pyramid or of a prism is equal to base times height for a prism. Now, if I have a cylinder, then the volume is equal to the area of the base, which is pi r squared times height. Okay? Now, for our prism, if I go to a pyramid, it takes 3 of the pyramids to fill the prism. So the volume will equal 1/3 the area of the base times the height. Okay? And then if I go from the cylinder to a cone, volume is going to be equal to 1/3 pi r squared times height. Okay, so that takes care of volume. Now, on the other hand, we still have to deal with surface area, okay? So, let's see. Surface area for a prism. Well, the surface area